Alrighty, this one, now we're going to be working on some more math-related stuff. I'm going to be working on factoring now, which personally I think is very useful no matter what math you're in. Algebra, geometry, algebra 2, college algebra, etc. The only one might be stats, but other than that, you're going to pretty much use this from algebra 1 all the way through. So, I'm going to start off with a relatively simple problem. X squared minus 4x minus 45. 45. And now what we want to do is try and factor this. Now, there are multiple methods to factoring. Well, I guess we'll not factor it. We're going to solve for its zeros. The zeros of an equation are where if you were to graph it, it would... This is a parabola. And parabolas are this kind of shape. Now, the zeros are where it crosses over the x-axis. So right there and right there. So, solving for zeros from an equation is pretty simple. There are multiple ways to do it. Right now, it's factoring. So, factoring this, what you want to do is see what multiples of this, so we'll say what multiples of this are there. There are 15 and 3. And then what multiples of 3 are there? And it's just 1 and 3, so that's a prime number, so we'll leave that. And what multiples of 15 are there? Well, that would be 5 and 3. And then both of those are prime numbers, so we can leave those. Now, if we notice, we can take 2 3s and a 5 to multiply to 45. Now what is that? 9. So I'll write over here. Whoops. Right over to the side. 9 and 5. So what you want to do is take multiples of this number, the last number, and see which ones will add up to this middle number. Now you might be saying, oh well, none of these look like they'd add up. 3 and 15, that's 18, and 5 and 9, that's 14. But this negative sign right here, the negative is very important. So you want numbers that will add up to, or multiply to negative 45, but will add up to negative 4. And that happens to be 9 and 5, but the 9 is negative. So that means negative 9 times negative 5 equals negative 45, which is this one right here. And then negative 9 plus 5 equals negative 4, which is this one right here. Perfect. So now, all you do is separate this x out into, or x squared into two x's, so you have x minus 9 parentheses x plus 5. There we go. Now, it was a pretty easy problem to factor, so we'll do another one. Let's see which one looks good. I think we'll do, yeah, x squared. What do we do? Plus, yeah, we'll do x squared plus x minus 42. Alright, do the same thing we did for the first one. Look at the factors of 42, which are, I think the only one, no, not the only ones. We have 7, 6, 2, and 21, and 3 and 14. So something times something equals negative 41 and adds to positive 1, because that's what's right here, positive 1. Even though it doesn't look like there's anything there, it's a positive 1. So, negative 41, or not negative 41, that's supposed to be a 2. Negative 42 would be 6 and 7. Those are 1 apart. So, thinking, how do we get 6 and 7 to multiply to negative 42, but to add to 1? Negative 6, 7 minus 6, 7 minus 6 equals 1. That's good. And then negative 6 times 7 is 42, or negative 42. So that's looking good right there. So that means we take, again, our x, separate it out into 2, get x minus 6 times x plus 7. So look at that. And then if we want to check our work, we can do something called the FOIL method. Little disclaimer, I did look up what FOIL means. The acronym stands for first, outside, inside, last, which is the order you multiply the terms in. I do explain it in the video, but I feel like the acronym might help it make a little more sense. So first, outside, inside, last, which is where we take u. I don't remember what the acronym stands for, but you take this, you take the outside, multiply it by the outside, multiply it by the inside, and then inside by outside, and then u by u. So if we multiply x and x, we get x squared. And if we multiply x times 7, we get plus 7x. And then if we take negative 6 times x, we get minus 6x. And then if we take negative 6 times 7, we get negative 42. And then if we simplify, we end up getting x squared. That's a horrible 2. X squared minus, not minus, plus x, because simplify that, we get 7 minus 6 is 1, minus 42, which is our original equation, all the way back up here. So that is perfect. All right, moving on to a little more difficult of a problem. Let's see. Yeah. I like this one. Yeah, we'll do these problems. So, a little more difficult one. This one involves coefficients rather than just having a 1 in the first place. It has an actual number there. So 3x squared plus 16x plus 5. So now you might be thinking, what do we do for this? It's actually not much harder than when there's a 1 in this place. I just didn't tell you something, that when there's a 1 in that place, what you do is you multiply this by this, and then you take that number and see what factors up to it. But when there's a 1 in that place, you can just look at this back one here. So what we do is we take 3 times 5, which would be, let's do it, 3 times 5 equals 15. So what multiplies to 15 and gets you 16? Well, that's pretty easy. 15 plus 1 equals 16. Because 15 equals 15 times 1, so that gets us our 15. And then 15 plus 1 gets us our 16, which is right there, and the 15 there. So those are both good. And then what we do here, rather than just separating this out into like 3x and 3x, what we have to do is do something called grouping, which is where we take our different sections, which would be this. Well, we do grouping after we separate this middle term into its 2 components. So you end up with 3x squared plus 15x plus x, 15 and 1 right there, plus 5. Now you might look and see, well, this is just an expanded form of this. It is, but that is where grouping comes in. We separate this and this and this and this. So we end up with 3x squared plus 15x plus x plus 5. And then what we do from here is we take out oh crap, I'm blanking. Oh yes, we take out the highest common I think it's called the highest common denominator of each of these. So for this first one, the highest common denominator would be 3x. 3x squared is 3x times x, and 15x is 3x times 5. So you can take out a 3x of both of those. So in the front, you'd write 3x times x plus 5. Now over here, the highest common the highest common denominator of both of these is 1. So because 1 times x is equal to x and 1 times 5 is equal to 5, and that's the highest any of those go. So you take out the 1 plus 1 times x plus 5, and now you notice these two are the same, which means we've done it correctly. So now we're left with these two and these two on the outside. So what you do is you take the stuff on the outside, 3x plus 1, and put it in parentheses, and then take the stuff on the insides and do x plus 5 and group it. And then boom, that is that problem factored all the way out. Now again, if you want to check, you just multiply them out. That times that, that times that, that times that, and then that times that. And then you simplify your problem from there, and you should get the right answer. Or what, not the right answer, the problem you originally started with. Overall, factoring is pretty easy once you've got it down. The learning curve for it is pretty high. It does take a while to recognize the patterns that are needed to factor. But once you've got it down, you're never going to forget it. Trust me on that one. But it's very useful for all math. Like I said, the only one that you probably wouldn't use it on is AP Stats. But, I mean, who knows? You might. But I can say for sure, Algebra 1, Geometry, Algebra 2, College Algebra, Pre-Calc, Calculus, just about all the math that Miege offers, or most any school would offer, you're going to need factoring. Anyway, goodbye, and happy studying.